Welcome to qnawire.
Alright, so this is a fun little problem involving scales inside of elevators. So the most important piece of information we need is your weight, your hypothetical weight. And this problem, which we're saying is 625 newtons. So they don't tell us what your mass is, which will also be useful later. So let's just go ahead and solve for that right now. So you can find your mass by dividing your weight by the gravitational acceleration near the surface of the Earth, which is 9.81 meters per square second. And then we find that our mass, which we'll use for this problem, is 63.7 kilograms. Good. So we can now begin the problem, and even before we begin part A, they tell us to draw a free body diagram, which is a good exercise to do. So this is a picture of you. You are a box, and inside an elevator there are two forces that are acting upon you. One is, of course, your weight from the omnipresent force of gravity, and the other is a normal vector, normal meaning perpendicular, and the basically the floor pushing back up against you so that you don't go falling through the elevator. So that's normally in equilibrium, except when the accelerates, when it starts to move. So in our problem, we're saying that the elevator is accelerating at a rate of 2.50. So that's an A for acceleration, 2.50 meters per square second in the upward direction. So, in other words, the net force acting on you is going to be, I'm getting this from the free body diagram, the normal force minus your weight. And that is also going to be equal to ma, as Newton's second law tells us. So, what is the normal force needed to achieve the acceleration of 2.50 meters per second? Well, let's solve for it. Let's add w to both sides of this equation, so that we end up with n is equal to weight plus ma, and then we actually know all those quantities, so we can go ahead and plug it in. We know your weight. We solve for your mass in the very beginning, which is 63.7, and then the acceleration is 2.50 meters per square second. Plug that into a calculator, and then at the end of the day, you'll get a value of 784 is how hard this, or what the scale would read, because that's how hard the floor is pushing up against you in the moment when the elevator begins to accelerate. Okay, so that was part A. Part B, if you are holding a block by a string in the elevator, because that's what you're doing, then what would be the tension force on that string? So this is an accurate picture of the block. It kind of looks like you, but we have a downward force of gravity acting on the block, and then we're going to call this MP. Package, it's a package, sorry, MP, where P stands for package. So because you're holding it by a string, it's not a normal force that's, preventing the package from falling to the floor, but rather a tension force. We're going to call that T. So T is pushing up against the force of gravity, and then we know that the package mass is 3.85 kilograms. And so it's the identical physics that's holding up this package. So we can go ahead and calculate the total forces or tally them up from our free body diagram. So in order to achieve that acceleration of 2.50 meters per square seconds, it's going to be the tension subtracted from the force due to gravity, and it's going to give us ma, where m is specifically the package mass. So now we can go ahead and solve for the tension force by adding the weight to both sides, and then we can actually group some factors together, namely the mass, and then plug in numbers in order to solve for that tension. So we have 3.85 over here, and then we're adding 2.5 to 9.1. Sorry, I'm running out of room here. 9.1 being force due to gravity. Plug that into a calculator, and then you get that your tension force is equal to 47.4 newtons. And we're done.